Hi there, my name is Mitch Harlabidis, and on this video we will see how we can calculate the trigonometric ratios of negative angles. So after this video we will be able to expand our ability of calculating trigonometric ratios of even more angles. Let's do the whole process through the following guided inquiry I have created. Recall the positive direction of drawing an angle and we'll be reminded that it's the anti-clockwise direction within a unit circle. Now draw an angle of 200 degrees. We all know, or at least we should all know, that in order to draw an angle within a unit circle, I always begin by drawing the first side of the angle in a way that it lies on the positive horizontal direction, and then moving in the anti-clockwise manner, which is the positive direction of drawing an angle, we go up to the point of completing the needed angle's size. So it's 90 degrees first, then it's another 90 degrees, and then another 20. So this should be 200 degrees. Now, let's do a second angle on the unit circle at the right. I'm going to use the green this time, but look, the angle this time should be of minus 160 degrees. Well, the minus only signifies the direction. If the positive direction is the anti-clockwise one, then the minus, the negative direction, should be the clockwise one. So, again, by lying on the positive horizontal direction, we go up until the point where the size of 160 has been met. So let's assume that it should be about that. So this is the angle of 160. This is 90. This is 70. And then it says name the endpoints as A and B respectively. This would be B, and similarly, this would be A. Copy the two above angles in the same unit circle that follows. Okay, let's do this as well. We have the 200 degrees, and now let me explicitly write them. 90 degrees, another 90 degrees, takes us up to 180, and then to 20 degrees, and the minus 160, so that would have been 90 as well, and another 70. By doing so, I can easily tell that both endpoints A and B are exactly one on top of the other. Now, how can this help us? Remember that on the unit circle, we introduced a sort of a poem. I'm gonna rewrite it here. We said that after drawing an angle theta, we look at the endpoint. And the poem was like this. Since in order to get to M, I had to draw an angle of theta degrees, let's say, or radians later on, then the coordinates of M can be written as cosine theta, sine theta. How can this poem be useful in our case? Let me apply that for point A. Since in order to get to point A, I had to draw an angle of 200 degrees, then the coordinates of that can be written as cosine 200, comma, sine 200. Similarly, since in order to get to point B, I had to draw an angle of minus 160 degrees, then the coordinates of B can be written as cosine of minus 160, sine of minus 160. What did I just say before? That A is on top of B, B is on top of A, which means that these two pairs of coordinates actually represent the same point, which makes them equal to each other. And that's the key of this video. Now, regarding these two angles, they are called coterminal simply because their second side is the same and simply because the end point at which their second points cut the unit circle are identical. Now, to be more specific, it's not just that. Two angles will be called coterminal if, first of all, one is positive and the other is negative, and B, when the sum of their absolute values is 360 degrees. So this is the most common definition of coterminal angles. One of them is positive, the other is negative. If we add the sum, if we add their absolute values, we should get 360. How can we find, therefore, given an angle, its corresponding coterminal angle? Well, simply take its absolute value and subtract it from 360. For instance, the coterminal of 150 degrees of minus 150 is 360 minus absolute value of minus 150, which means 360 minus 150 equals to 210 degrees. If we were working with radians, we would have said that the coterminal of minus 3 pi over 4 is 2 pi. Instead of 360, now I'm working with radians, so the corresponding one is 2 pi minus the absolute value of negative 3 pi over 4, which means 2 pi minus 3 pi over 4, which is 5 pi over 4 radians. So once you are given a negative angle, all you have to do to find its corresponding positive coterminal one is to take its absolute value, whether it's given in degrees or in radians, and take it out from 360 if it's given in degrees, or from 2 pi if it's given in radians. The result of this operation should be the corresponding positive coterminal angle. We just said that, but let's say that again. What can you tell about the trigonometric ratios of two coterminal angles? They are the same. They are the same. Hence, can you suggest of a methodology that can be followed to find the trigonometric ratios of a negative angle? Certainly, we would say, given a negative angle, I would say find its corresponding positive coterminal and then continue with finding that angles trig ratios. Let's work an example. Find the trigonometric ratios of minus 150 degrees. So negative 150 is obviously a negative 1. We should find the positive corresponding coterminal one. How exactly should I do that? I should take the absolute value of minus 150, which is 150, and take it out from 360. By doing so, we end up with 210, which means that the angle of minus 150 degrees and the angle of 210 degrees are coterminal, which means that the trig ratios of minus 150 degrees are the same as the trig ratios of 210 degrees, which means that so far I should be able to write that sine of minus 150 is sine of 210, and similarly cosine of minus 150 is equal to cosine of 210. But this only means that now I need to find the trig ratios of this new angle of 210. Well, this will initiate the methodology I already know, which is what? First of all, let's try and find the quadrant in which 210 lies. Obviously, it's third quadrant. What do we know about the forms of an angle on this quadrant? We know that they are always of the form 180 plus theta. Now I need to calculate the corresponding angle theta. If 210 can be written as 180 plus theta, then this means that 210 minus 180 is theta. So I managed to relate the angle of 210 with the angle of 30 degrees. And it seems that things are working really well for me because the angle of 30 degrees is actually one of the angles that I should know its trig ratios by heart. How can I use the unit circle for that? Again, it's about the poem. Since in order to get here, I had to draw an angle of 210 degrees, then the coordinates of that point can be expressed as cosine 210 and sine of 210. Since in order to get here, I had to draw an angle of 30 degrees, then the trigonometric ratios of that can be written as cosine 30, sine 30. Think about symmetry. If I'm working on this quadrant, the point should be x, y. Then, on the third quadrant, it should be minus x and minus y. What does this shows us? That both x's and y's are opposite, which means that cosine of 210 should be minus cosine of 30, which is something that we should know by heart is root of 3 over 2. And sine of 210 is minus sine of 30, which is equal to minus 1/2. Let's work finally an example with radians. Let me clear this for you. And let's work with an example on radians. Let's try to find out the tangent of minus 2 pi over 3. First of all, this is a a negative angle given in radians. So I'll begin by finding the positive coterminal one. How should I do that? I should take the absolute value of minus 2 pi thirds and I should subtract it from 2 pi. By doing so, I would get 2 pi minus 2 pi thirds. This is the same as 6 pi thirds minus 2 pi thirds equals to 4 pi thirds. So this means that the angle of minus 2 pi thirds and 4 pi thirds are coterminal ones, which means that they have the same trigonometric ratios. So up to this point, I know that sine of minus 2 pi thirds is the same as sine of 4 pi over 3. Cosine of minus 2 pi over 3 is cosine of 4 pi over 3, respectively. Which only means that I need to find the trigonometric ratios of this angle, 4 pi over 3. To achieve that, I need to firstly understand in which quadrant this angle will be. How should I do that? We know that I have to compare it with the natural boundaries of the quadrants when in radians. This is pi over 2, this is pi, this is 3 pi over 2. It's easy to see that 4 pi over 3 is greater than pi, since after all, 4 thirds is greater than 1, which means that I should be working in third or fourth quadrant. I have an angle which is greater than pi. Now, in order to determine whether it's on the third or on the fourth, I should compare 4 pi thirds with 3 pi over 2. To compare two fractions, I can just cross multiply. 4 pi times 2, it's 8 pi. 3 pi times 3, it's 9 pi. Whatever holds for these numbers holds for the fractions above them. So 4 pi thirds is less than 3 pi over 2, which means that I'm working on the third quadrant. I know, however, that an angle on the third quadrant, when in radians, can always be written in the form pi plus theta, where theta is the angle in the first one. So, if 4 pi over 3 is pi plus theta, then this means that theta is 4 pi over 3 minus pi, which is 4 pi over 3 minus 3 pi over 3, which is pi over 3. So, I have just related 4 pi thirds with pi over 3. Let's see how unit circle will assist us further. Since in order to get here on the first quadrant, I had to draw an angle of pi over 3 radians, the coordinates of that could be expressed as cosine pi over 3 and sine of pi over 3. Since in order to get here on the third quadrant, I had to draw an angle of 4 pi over 3 radians, the coordinates of that can be given as cosine of 4 pi thirds, comma, sine of 4 pi thirds. With regards to symmetry, it's easy to acknowledge that both x's and y's are opposite, which means that cosine of 4 pi thirds is minus cosine of pi thirds, which is equal to pi thirds 1 half, so minus 1 half, and sine of 4 pi thirds is minus sine of pi thirds, which is minus root of 3 over 2. But remember that in the beginning, I wanted to calculate the tangent of minus 2 pi thirds. tangent of minus 2 pi thirds. That would have been sine of minus 2 pi thirds over the cosine of minus 2 pi thirds, but I managed to find that sine, let's follow this, sine of minus 2 pi thirds would have been equal to sine of 4 pi thirds, which is equal to minus sine of pi thirds, which is equal to minus root of 3 over 2. So minus root of 3 over 2 over cosine of minus 2 pi over 3 is the same as cosine of pi over 3, which is the same as minus cosine of pi over 3, which is minus 1/2. So over minus 1/2. Let me zoom in again. So minus and minus are cancelled out, and we end up with square root of 3. And this is the process which once again shows us that we can now expand our findings of trigonometric ratios of negative angles. How? We calculate the positive coterminal angles and move on from there based on what we knew already. That's all. Please watch this video more than once if you think it's needed. I hope it helps. If, however, you still have issues, you still have concerns, you still need clarifications, please leave them below in the comment section, and I'll try to respond back as soon as possible. As always, thank you for watching.